Hi guys, so the next thing that we're going to talk about today is intracellular trafficking, or it can even be called vesicular trafficking. And since this PowerPoint is divided into 40 slides, I'm going to divide it each video to 10, so I'm going to cover 10 slides in each video. Okay, so let's begin. So what is intracellular trafficking? Intracellular trafficking is just the transport of molecules from one location inside the cell to another. So they move molecules from one place inside the cell to another. So that's why, and it can also be called vesicular trafficking. Okay, so there's two pathways. Obviously, there's the endocytic pathway and the exocytic pathway. The endocytic pathway obviously takes things inside the cell. So it's the internalization of molecules from outside the cell to inside the cell. So it transports it to the appropriate destination. So usually the pathway for that is from early endosome to late endosome to lysosome. And the pH throughout the way starts to decrease because decreased pH is important for protein-protein interactions and enzymatic functions. So after the endocytic pathway, that's when the exocytic pathway begins. And that's the exocytic pathway is just the transport of molecules that are made inside the cell to go back out to the plasma membrane or elsewhere in the cell. So this happens from the endoplasmic reticulum to the Golgi apparatus to the plasma membrane. But it could also be from the endoplasmic reticulum to the Golgi apparatus to the early endosome and then to the late endosome. It depends. So that was a lot of information that I just threw at you. So now we're going to slow down and take a step back and now talk about vesicular transport. And this is basically the Golgi apparatus is kind of like the FedEx station of the cell. So we have different kind of proteins that have different kinds of functions. So the coat proteins, they help collect the material, so they pack it and they protect it. Then the rab proteins and the tethers, they kind of truck it up and ship it. And then the snare proteins kind of place the package in your hand. So there are 3 steps. There's vesicular budding that involves coats, vesicular transport that involves tethering and docking, and then vesicular fusion that involves the snare proteins. And we're going to talk about that just in a moment. So you need to understand that there's 3 things. So for budding, always know when things are budded, you need proteins. And we're also going to talk about what budding is. So just for you to know in the future, budding requires coat proteins, targeting and transport requires RABs, tethers, motors, and microtubules, and fusion requires snares. So that's pretty much it for the first video, and then we're going to talk about the next 10 slides next.